Hello all, today we have got some exciting updates from DFINITY that will make your work on the internet computer more cost effective and secure. Whether you are testing advanced cryptographic features or working with Motoko, DFINITY's latest changes are all about making life easier for you. Let's get into the details now. Let's start with some fantastic news for developers testing chain key features on the internet computer. DFINITY has unveiled a cost-effective chain key testing canister designed to simplify and lower the cost of testing critical features like threshold ECDSA, threshold schnorr, and the upcoming threshold key derivation. For those of you who have been following these features closely, you will know that testing these directly on the mainnet was a costly and complex process. The fees associated with the Internet Computers Management Canister APIs are usually quite high, especially when experimenting with advanced chain key functions. But with this new testing canister, developers now have a much more affordable and accessible way to test these features without worrying about breaking the bank. So what exactly is the chain key testing canister and how does it work? The canister is a smart contract deployed on the Internet Computer's mainnet designed to mimic the APIs of various chain key features. These include TECDSA, T-Schnorr, and the upcoming VETKD. Normally, when using these features on the mainnet, developers rely on keys that are distributed across subnet nodes. But this new testing canister uses a hard-coded cryptographic key. This design significantly reduces the cost of testing since developers no longer need to access the standard APIs that come with associated fees. However, it's important to note that this canister is intended for testing only. The use of a hard-coded cryptographic key makes it insecure for production purposes. So, while it's a perfect tool for experimenting with features like TECDSA, T-Schnorr, and VETKD, it is not recommended for any sensitive or security-critical operations. The chain key testing canister is already live on the mainnet and you can find its canister ID at this address. It's accessible via the Candid UI or through the developer dashboard, so you can get started with your testing immediately. At the moment, the canister is free to use, which is a great opportunity for developers to get familiar with these advanced features. However, DFINITY has mentioned that if the canister sees excessive usage, they may introduce minimal fees in the future. These fees, however, will be much lower than the standard fees associated with the production APIs, ensuring that it remains an affordable option for developers. One of the most exciting parts of this update is the transparency it brings to the table. The source code for the chain key testing canister is available on GitHub, so you can review it and even deploy your own instances. This gives you the flexibility to create your own private or public canisters tailored to your needs. Whether you are working on a personal project or need a dedicated instance for a specific use case, the ability to deploy your own version is a huge bonus. For the Internet Computer community, this marks a significant step forward. The canister offers a more cost-effective way for developers to test advanced chain key features on the mainnet, making it easier to experiment with TECDSA, T-Schnorr, and VETKD. It also paves the way for innovation by lowering the financial barriers that have often made testing these features expensive. This is an exciting development for the Internet Computer ecosystem. It will enable more developers to experiment and innovate, pushing the boundaries of what's possible with these advanced cryptographic features without the pressure of high fees. Moving on to our next big update, DFINITY has just rolled out a critical bug fix in the Motoko runtime system, addressing a significant issue that had the potential to affect a lot of developers. The bug was found in programs using the incremental garbage collector or enhanced orthogonal persistence, two features that many Motoko developers rely on for managing memory efficiently. To give you some context, this bug could have caused unintended memory writes or reads in your applications, leading to potentially disastrous issues. Although it was difficult to trigger as it depended on specific heap constellations and garbage collection schedules, it was still an issue that all developers using these features needed to be aware of. The bug was most likely to affect applications that rely heavily on incremental garbage collection or enhanced orthogonal persistence, which are used to optimize memory and ensure long-running programs continue to run efficiently. Fortunately, this issue has now been fixed with the release of Motoko version 0.14.3, which is available through DFX version 0.24.3. If you have been working with either of these features, it's highly recommended that you update to the latest version of DFX. The update is simple and straightforward. Just run DFX VM update to get the latest version and then deploy your Motoko applications with the DFX deploy network IC command. By updating to the latest version, you will ensure that your applications are free from any risk associated with the bug and can run more securely. For developers who like to dive into the technical details, DFINITY has published a GitHub security advisory that outlines the nature of the bug and the steps taken to fix it. You can find the full advisory in the Motoko repository on GitHub. It's a great read for anyone who wants to understand exactly how the bug was addressed. The fix is crucial for those who rely on incremental garbage collection and enhanced orthogonal persistence, ensuring that your applications can run smoothly without the risk of memory-related issues. As we all know, memory corruption or unintended writes can cause serious bugs, so this fix will undoubtedly improve the stability and reliability of Motoko programs across the board. These updates are a major step forward for both the internet computer and the broader development community, ensuring a more cost-effective, secure, and reliable experience for everyone involved. Be sure to subscribe to our channel for more updates and follow DFINITY's progress as we continue to push the boundaries of what's possible with the internet computer. Thanks for tuning in and happy coding!